Good morning, my dear students. In this particular video presentation, we'll discuss some more problems meant for class 12 of CBSE. The first problem meant for today, it goes like this. If 4k156 is singular, find the value of k. Just I'll move on to the problem directly. It's not a difficult problem. 4k156 is singular. If this is singular, find the value of k. That's what I'm supposed to find out. Just listen carefully. You know very well, it may be a 2 by 2 square matrix or 3 by 3 or 4 by 4. Any square matrix whose determinant value is 0 is called a singular matrix. Just recall the formula behind this particular problem. If the determinant value of any square matrix is 0, it is supposed to be singular. If determinant value of a square matrix is not equal to 0, it's called non-singular, which will automatically imply you 4k156 is supposed to be 0. You're supposed to use this symbol for matrices, this bracket. The vertical symbol is supposed to be used for determinants. Here you mean to say 24k minus 5 is equal to 0. 24k is equal to 5 implies k is equal to 5 by 24. Therefore, value of k should be 5 by 24 for the given matrix to be singular. That is the conclusion you are supposed to give. Okay, let me interpret the question this way. Find the value of k if it is non-singular. How do you go about it? As I already told you, when I am going to discuss any problem, I won't discuss only the answer for that particular problem. I'll discuss similar questions related to that cases. I'll be thinking about various possibilities with respect to that particular question. Therefore, here if it is given as non-singular, I'll put not equal to 0 here. I'll put not equal to 0 here. I'll put not equal to 0 here. I'll put k not equal to 5 by 24. The conclusion what I'm going to give here is, if it is non-singular, k can take any real value other than 5 by 24. That is the answer you are supposed to give. I repeat, if the question is given as if the given matrix is non-singular, find the value of k. I'll write instead of singular, I'll write it is non-singular. Implies this is not equal to 0. Implies this is not equal to 0. Implies this is not equal to 0. Implies k not equal to 5 by 24. Therefore, give the conclusion, k can take any real value other than 5 by 24 for the given matrix to be non-singular. That is a condition you are supposed to give. Therefore, whenever I discuss any problem, if I discuss something, any other question related to that, you be prepared for that also. Be prepared for that also. It will be always, that will definitely help you to apply your mind in your examinations. If it is given in a different way, what happens? You should be able to think over and then answer. Okay, next question goes like this. Evaluate integral 4x minus 1 dx divided by x square plus 6x plus 10. Actually, the application here is whenever you have an integral of the form integral px plus q dx by ax square plus bx plus c. Numerator is equal to capital A into d by dx of the quantity in the denominator plus capital B. Now compare the coefficients of x and constant term and then try to get the values of a and b. After you get the values of a and b, you will proceed with the integration. Therefore, let me go with the application now. Let 4x minus 1 is equal to a into d by dx of x square plus 6x plus 10 plus b, which implies 4x minus 1 is equal to a into 2x plus 6 plus b, which implies 4x minus 1 is equal to 2ax plus 6a plus b. Now compare the coefficients. 2a will be is equal to 4 and 6a plus b is equal to minus 1, which implies a will be 2, then 12 plus b is equal to minus 1, which will imply you b is equal to minus 13. Therefore, my integral now becomes 4x minus 1 dx by x square plus 6x plus 10 will be is equal to twice of integral 2x plus 6 dx by x square plus 6x plus 10 minus 13 integral dx by x square plus 6x plus 10. Now for here it will be of the form dt by t minus 13 integral dx by x square plus 2 into 3x plus 9. Add 9 and subtract 9 plus 10 minus 9 I will have. Where what is my t you write? T is nothing but the denominator x square plus 6x plus 10. This will be 2 log mod t minus 13 integral dx by x plus 3 whole square plus 1, which is equal to 2 log mod x square plus 6x plus 10 minus 13 integral du by u square plus 1, where u is x plus 3. Therefore 2 log mod x square plus 6x plus 10 minus 13 into tan inverse u plus c. Therefore this will get reduced to automatically 2 log x square plus 6x plus 10 minus 13 into tan inverse x plus 3 plus c is the final answer. That will be the final answer. I repeat the whole process once again. It's not a difficult task. The rule says numerator equal to a into d by dx of the quantity in the denominator plus b. That's the application. Now for 4x minus a into 2x plus 6 plus b. 4x minus into 2ax plus 6a plus b. Compare the coefficients. 2a is equal to 4. 6a plus b is equal to minus 1. A becomes 2. 6 into 2 becomes 12. B becomes minus 13. Now for twice of integral dt by t, where t is the denominator, minus 13, I'll try to make it as a perfect square. After making it as a perfect square, if it comes under the format dx by x square minus a square, I'll use the formula 1 by 2a log mod x minus a by x plus a. If it comes under the format integral dx by x square plus a square, I'll use the formula 1 by a tan inverse x by a. Therefore, this 6x can be written as 2 into 3x. A square plus 2ab becomes a perfect square only when by adding b square. Instead of b, I have 3. 3 square is 9. Add 9, subtract 9. This x plus 3 can be replaced by u. Du by u square plus 1. 10 minus 9 is 1. Therefore, it's a direct application tan inverse u. For 2 log x square plus 6x plus 10 minus 13 tan inverse x plus 3 plus c will be the final answer. Will be the final answer. That will be the final answer. That is the final answer. Since there is more time, I think I'll be able to do one more problem here. Okay, I'll try to do one more problem. Okay, there is enough time here. There are only 7 minutes since these two problems are little bit not lengthy. These two problems are not lengthy. I'm able to finish in 7 minutes. I'll take one more problem. Just listen. I'll take another problem. Just see here. The problem goes like this. Evaluate integral 0 to 12 root x dx by root x plus root 12 minus x. I just name it as a I. Okay. Also I is equal to integral 0 to 12 root of 12 minus x dx by root of 12 minus x plus root of 12 minus x. I'll get the application here is 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. That's the application. Therefore, this will become 0 to 12 root of 12 minus x dx by root of 12 minus x. Here 12 gets cancelled plus root x. This is also I. Add 1 and 2. I have the same denominator. I'll be able to add the numerators root x plus root 12 minus x by root x plus root 12 minus x dx. This will get cancelled. It will be x 0 to 12, which is of course 12 minus 0, which is 12. Now for 2i becomes 12 implies I becomes 6. Let me just repeat the whole process. Integral 0 to 12 root x dx by root x plus root 12 minus x. I call it as I. This is what I am supposed to find out. Also I equals 0 to 12 root of 12 minus x dx by root of 12 minus x plus root of 12 minus 12 minus x. Here minus into minus become plus x here. Since the denominator is the same, if I am going to add 1 and 2, okay, this is my equation 2. which is 2. Yeah, this is 2. Add 1 and 2. LHS becomes 2i. RHS, I have the application of a by c plus b by c to be a plus b by c. I have the common denominator. But listen carefully, if anybody cancels root x, root 12 minus x separately, that is totally wrong. That is meaningless. Cancel fully. Then integral dx is nothing but x. Apply upper limit 12, apply lower limit 0. Now for 2i happens to be 12, I happens to be 6. Again, there is a generalization here. If you are given 0 to a root x dx by root x plus root of a minus x, apply the rule. I'll get the answer to be a by 2. Now for if any such case, if the upper limit is 12, my answer will be 12 by 2, 6. The upper limit is 100, my answer will be 50. If the upper limit is 75, my answer will be 75 by 2. You can write it in fraction also, or you can leave 75 by 2 as it is. Accordingly, if it is upper limit is 75, I'll get 75 minus x here. Upper limit is 200, I'll get 200 minus x here. I repeat, if you are given 0 to a root x dx by root x plus root of a minus x, that's the condition given. A can be any real number. Okay, then applying this rule and proceeding, I'll get the answer to be a by 2. If you remember this particular rule properly, you'll be able to check the final answer in your CBSE after doing the process systematically like this, and you can write the answer ABCD quickly in your competitive examinations. Okay, in your competitive examinations. As I already told you, I think there is enough time. I think I can do one more problem also. Okay, I'll try to do one more problem. It's only 11 minutes. I'll try to do one more problem. I'm doing each video for maximum of 15 minutes. I already told you. I'll try to do one more problem. Okay, it's not at all difficult. When the letters of the word probability are permuted, find the probability that the arrangement starts with y. See, this is the question given to you. This is the question. Okay, this is the question given to you. Let me just see how we go about the answer. The word probability, you may think it's a problem from 11th standard, but such a question can be given in your examination. Word probability has how many letters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 letters. Namely, what are they? 1P, 1R, 1O, 2 B's, 1A, 2 I's, 1L, 1T, 1Y. You can just check 1, 2, 3, 5, 6, 8, 10, 11. It's correct. 1P, 1R, 1O, 2 B's, 1A, 2 I's, 1L, 1T, 1Y. Okay, then total number of arrangements of the letters of the word. Letters of the word is equal to 11 factorial by 2 factorial into 2 factorial. If the arrangement starts with y, number of such arrangements will be is equal to 10 factorial by 2 factorial into 2 factorial. Other than y, we arrange everything, and similar to your Scrabble, you might have seen a game like Scrabble. After doing every other arrangement with the remaining letters, I'll insert y at the beginning. That's the real meaning of it. Okay, you may think why we are taking the letter y outside. After arranging every other letters other than y, I'll insert y at the beginning. That's the meaning of having so many arrangements starting with y. Now for remaining letters are 10, whatever repetition is there, the factorial should be written. Now for required probability will be is equal to 10 factorial by 2 factorial into 2 factorial divided by 11 factorial by 2 factorial into 2 factorial. This will anyway get cancelled. 10 factorial by 11 into 10 factorial, which will get reduced to 1 by 11 to be the answer. 1 by 11 to be the answer. Let me just repeat the whole process. The word probability has 11 letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's correct. Name the letters 1P, 1R, 1O, 2 B's, 1A, 2 I's, 1L, 1T, 1Y. It's correct. 1, 2, 3, 5, 6, 8, 9, 10, 11. You can just count. Okay, now for total number of arrangements of the letters, the word will be factorial of the total number of letters, 11 factorial, by product of factorials where the repetition is there. Therefore, there are 2 B's and 2 Y's. Therefore, multiply 2 factorial, 2 factorial there. Similarly, if the arrangement starts with Y, other than Y, there are 10 letters, out of which 2 B's and 2 I's are there. Such arrangements will be 10 factorial, 2 factorial, and 2 factorial. As I already told you, putting Y aside means after every other arrangement of the remaining letters, Y is inserted at the beginning. That's the meaning of the arrangement starting with Y. That's the meaning. For this is the number of favorable cases. This is the number of exhaustive cases. This is the N of S. This is the N of A. The event is A. Now for here 2 factorial gets cancelled. N factorial can be written as N into N minus 1 factorial. Therefore 11 into 10 factorial will make 10 factorial getting cancelled, which is there in the numerator. My final answer will be 1 by 11. Therefore 1 by 11 is the probability where the arrangement starts with Y. I'll check for the calculations once again. If there is any error, I'll add up. Otherwise, I'll upload as it is. Thank you, students, for patient watching.